Revit is a three-dimensional design and two-dimensional documentation application. Project workflow using Revit is similar in some ways to using traditional CAD programs, and in other ways is significantly different. In many cases, one person sets up the project. This can be done by the BIM manager or a project coordinator. Also, depending on the amount of Revit content you have, the setup process will be different. For example, if you already have custom project templates for the specific kinds of project you are working on, you can begin a project using a project template, link in the architectural model, and get to work. However, if you do not have any project templates, you will need to perform some additional steps. Just realize that Revit was created for building information modeling, and all the design will go into one building model. There are also other things to think about when beginning a project. Will work sharing be used in the project? If more than one person will be working on the project, then you will want to enable work sharing. Once work sharing is enabled, you need to determine how the work sets will be set up. Also, will the project be split into multiple models? For example, you can create a model for each discipline: mechanical, electrical, and plumbing. Or you can create a model for each area of the building, or for separate levels. When the project is split, you will have to link all the models together, just as with an architectural or structural model. However, the project does not have to be split. Remember that the goal is to create one building model where all the design information is coordinated. You should consider splitting the model only if the project is extremely large for better performance and management. Once you know how the project will be set up, you can begin creating views and sheets, as well as adding families to the project. These steps do not have to be completely finished before the team can begin work on the project, though. You will need to create plan views for each discipline as required by the project or your company standards. Revit recognizes architectural, structural, mechanical, electrical, plumbing, and coordination as disciplines. However, you can create subdisciplines under each discipline to create views as needed. For example, you may want to create subdisciplines for HVAC, hydronic, waste and vent, storm, fire protection, power, lighting, and systems. Also, when creating views, you may want to have working views and plotting views. Working views can be used by designers to add more descriptive tags and notes to aid in the design process, whereas plotting views are placed on sheets to be used in the final documentation. You do not have to create a working view for every single plotting view. For example, you may want to have a mechanical working view where all ductwork, piping, and equipment are visible. Then, you need to control the visibility and graphic settings of the plotting views so that only the required elements appear on the sheets and they appear as needed. Lastly, you can create sheets and add the views to the sheets. At this point, you have a good start to a project template and could save the project file as a template file. Once you are satisfied with the content that is available in the project for the design team to use, you can link in the architectural model and the structural model if they are available. Once the architectural model is linked in, you need to manage the datum elements. These include the levels that are associated with the floor plans, and the levels in the MEP model or models should match the architectural model. After that, you should create spaces to match the architectural rooms. Spaces are essentially containers for MEP information, such as area, volume, airflow, power loads, lighting, and so on. Once these steps have been completed, the design team can jump in and begin designing. Once a project begins, the first steps are almost always to establish design intent and begin performing initial calculations. You can create design analysis schedules as well as zoning and area plans to help you begin this process. You can also use Revit to calculate preliminary loads. Different disciplines have different methods for doing this, but they all have a way to get a reasonable idea of the loads. For HVAC, these loads can be generated by using an area method, or by using the Revit load engine as a first pass. For plumbing, a design analysis schedule that quickly tabulates plumbing fixture counts can be used to size the water service and domestic water heaters. An estimate can be made for fire protection based on square footage as well. For lighting, preliminary loads are often dictated by energy codes in a maximum density per area. Rules of thumb for power densities are common for power load calculations as well. Once you have calculated initial loads, you can begin placing head-end equipment. There is a misconception that all objects in Revit need to be modeled in a very complex way. For years, mechanical and electrical engineers have depicted equipment as boxes and cylinders. Certainly for the design intent stage of the project, generic mechanical and electrical equipment of the appropriate Revit category, physical size, and name can be placed in the model quickly. Later on, the head-end equipment can be substituted for more detailed equipment. Once the head-end equipment has been placed, you can begin creating room layouts. In Revit, this includes placing actual elements to represent real-world objects, such as air terminals, plumbing fixtures, and lighting fixtures. After that, you can create distribution systems by running ductwork, piping, conduit, and cable trays as necessary.